Your phone versus Google's 1000 servers. Which one is more powerful? Stick around because by the end of this video, you will understand exactly how both work together every single time you search something online. This is next lecture in mobile computing series, mobile versus distributed computing. Okay, real question. You just Googled something, the answer appeared in zero point 0.3 seconds. How? Here is what actually happened. On your site, your phone sent a search request over 4G to Google server. That's mobile computing. Simple. On Google's site, 1000 servers simultaneously broke your query into tiny pieces. Each server handled one piece. They combined the result and sent it back. That's distributed computing. And here is the mind blowing part. Both of these happened at the same time in under half a second for your search right now. Netflix, your phone streams it, mobile. But thousands of CDN servers around the world are surviving that video to you. Distributed. Flipkart, your app places the order, mobile. Server clusters processes all crores of orders, distributed. Google Maps, GPS on your phone, mobile computing. Real-time traffic from 1 billion devices, distributed computing. Same company, same app, both paradigms, every single time. Okay, let's lock in the definition. These are some exam marks right here. Mobile computing is computing that moves with you. Portable wireless devices, your phone, your tablet, your smartwatch, accessing data and apps without cables or a fixed location. You move, it moves. Distributed computing is many computers working as one. Multiple computers connected on a network, sharing tasks in parallel, appearing to the user as a single powerful system. Here is the key difference in one line. Write this down. Mobile, one device, one user moves around. Distributed, many computer, one goal stays fixed. These 2 marks in your exam right there. You are welcome. Now the exam gold. 5 key differences. I'll go fast, pause and screenshot this slide. 1. Mobility. Mobile devices moves with the user. Distributed nodes are fixed. A compute server doesn't walk to a coffee shop. Second, network. Mobile uses wireless, Wi-Fi, 4G, 5G. Distributed uses wired, Ethernet, fiber optic. One is shared and variable. One is dedicated and fast. Third, power. Mobile runs on battery. Every operation costs energy. Distributed plugs into the wall, runs at full speed 24/7, no battery to worry about. Fourth, focus. Mobile is user centric. It's designed around you, your location, your preferences, your identity. Distributed is task centric. It doesn't care who you are, it's just want to finish the computation. Fifth, scaling. Mobile is limited by your device hardware. You can't add a second processor to your phone. Distributed scales by simply adding more nodes, need double the power and double the servers. 5 differences done, that's 5 mark answer in 60 seconds. Now let's make this real. Same industry, same app, both paradigms side by side. Flipkart, you browse on your phone. GPS finds your delivery location. You pay via UPI. That's mobile. Flipkart's backend. Thousands of servers process all orders simultaneously, run recommendation algorithms in parallel, coordinate warehouses. That's distributed. Netflix. You stream on mobile anytime, anywhere. Netflix backend. CDN servers in 50 plus countries serve that video to you instantly without buffering. Google Maps. Your phone navigates using GPS. Google's backend, a distributed system tracking 1 million devices in real time for traffic updates. PhonePe UPI. You scan and pay in seconds. The backend distributed banking system processes crores of UPI transactions per second with zero errors. Notice the pattern. Mobile is always the front end, the part you touch and see. Distributed is always the back end, the part doing the heavy lifting invisibly. They are not rivals, they are partners, best friends actually. Now, this is the slide most students skip, and that's why they lose marks when the examiner asks about similarity. Don't be that student. Six similarities. Both need a network. Remove the network from either, both collapse immediately. Both use client server. Your app is the client, the server response. Same pattern in both paradigms. Both face security challenges. Mobile has device theft and Wi-Fi attacks. Distributed has node intrusion and data breaches. Both need strong security. Both aim for transparency. You don't know which tower connected your call. You don't know which of Google's server answered your search. Both hide their complexity from you. Both want to scale. Different methods, same goal. Both share resources. Your phone access Google's cloud. Distributed nodes share CPU access the cluster. Six similarity. If examiner asks for three, pick up any three easy marks. Quick architecture walkthrough because this is a diagram question waiting to happen. When you order pizza on Swiggy, here is exactly what happens step by step. Step 1, you will tap on the Swiggy app, mobile layer, your device. Step 2, request sent over 4G. Wireless network leaves your phone. Step 3, API gateway receives it. Authenticates you. Cloud bridge, still not at the main server. Step 4, server cluster. Processes your order, assigns a delivery rider using an algorithm. This is a distributed computing happening. Multiple servers working in parallel. Step 5. Databases. Nodes saves your order. Triggers notification to you, the restaurant and the rider simultaneously. All 5 steps under 3 seconds. Mobile on your site, distributed on Swiggy site. That's modern architecture. Screenshot the slide right now. This is your 10-mark answer template. Definition. Mobile, portable wireless device, anywhere, distributed multiple computers network as one. Mobility, core features, device moves, not applicable, nodes are fixed in distributed. Network, mobile wireless, distributed wired, power mobile, battery limited and critical, distributed add more nodes. Wall power, scalability, limited by hardware, add more nodes. Power tolerance, device fails, everything stops in mobile, distributed, one node fails, system continues. Location awareness, mobile, yes, GPS is core, distributed, no, irrelevant. Processing, mobile on device plus clouds, distributed parallel across thousands of nodes, and the magic sentence that takes you from 8 marks to 10 marks. Write this at the end of your answer. Mobile and distributed computing are complementary. Mobile in front end providing user experience, distributed is back end providing scalable processing. Done. Final recap. Mobile computing device travels with user wireless battery powered, one user personalized, context aware front end. Distributed computing nodes fixed, wired, wallpaper, many computers, one task, scalable backend. If you can say those two lists from memory, you can answer any exam question on this topic. Test yourself right now. Pause the video and write them down from memory. Come back in 60 seconds. How did you do? Drop your score in the comments. 0 to 12. I read every single one. You mastered this lecture mobile versus distributed computing. Now, real talk, if this video saved you 2 hours of studying, the least you can do is hit that like button. It takes 1 second and helps thousands of other students who are desperately searching for this content right now find it. Subscribe and hit the bell. Next lecture on mobile computing architecture is dropping soon and it builds directly on what you just learned. And share this one with one classmate who has exams coming up. Just one, they will actually thank you for it. Comment below which app do you use every day that's run both mobile and distributed computing. I read every comment, best answer gets pinned. See you in next lecture. You are doing great. Keep going. Thanks for watching.